Okay, so today we're talking about, we're in chapter 6, numerations and number theory. We're doing section 6.5 on prime numbers. Okay, so number theory is a mathematical discipline that's based on the natural numbers. Okay, so natural numbers are 1, 2, 3, and they go all, they just keep going all the way up to infinity. So these are our counting numbers. They're the number that we start with when we count. Okay, so the mathematician Carl Gauss established lots of theorems in number theory. This is an entire branch of mathematics. So Gauss called mathematics the queen of the sciences, and then number theory the queen of mathematics. Okay, so this is a very important topic in mathematics. So number theory is an important topic of math, important part of math. Okay, what ends up happening is that things that we can do with numbers, we end up being able to do algebraically as well. Okay, so the big topic in number theory has to do with the idea of a divisor or factor. Okay, so these are some vocab words that we should know: divisor and factor. So the natural number a is a divisor or factor of the natural number b, provided that there exists a number j, so that aj equals b. Okay, so we're working again only with natural numbers here. A and j, and then we set it up so that when we multiply them together, we're going to get another natural number b. Okay, so that means that a is a divisor of b, or j is a divisor of b. Both of these would be divisors. Okay, so as an example, so if you look at example 1, okay, in example 1, the two divisors that are used here are 6. Okay, so if we look at 6, okay, we can write 6 as 1 times 6, or 2 times 3. Okay, so that means that 1 is a divisor of 6, 6 is a divisor of 6, okay, 2 is a divisor of 6, and 3 is a divisor of 6. Okay, and that's because when we divide 6 by 1, we get 6, remainder 0. When we divide 6 by 6, we get 1, remainder 0. When we divide 6 by 2, we get 3, remainder 0. And when we divide 6 by 3, we get 2, remainder 0. Okay, so because the remainder is 0, that's how we know it's a divisor. Okay, but when we try 4, right, because we've done 1, 2, 3, so the only two other possible factors of 6 would be 4 and 5. But when we try to do 6 divided by 5, we get 1, remainder 1. So 5 is not a divisor. And then similarly, if we try to divide by 4, we get 1, remainder 2. So that means that 4 is not a divisor. Okay, so for something to be a divisor, it has to divide the number evenly, so that the remainder is 0. Okay, expanding on our definition. This is the idea of what is a divisor. So you can't see that. Okay, so is it a divisor? You have to divide the number so that the remainder is 0. So I'm going to pause and give you a moment to go ahead and try the next two parts of example 1, which are 42 and 17. Okay, now that you've had a chance to try these, let's talk about it. So when we look at the divisors of 42, again, we could try all the natural numbers from 1 all the way to 42, but that's a lot. So what we're going to do is we're going to kind of go through them as we can, and then we're going to kind of match them up with the other factor that gives us that. So when we think about 42, we could write 42 as 1 times 42. Whoops. We could do it as 2 times 21. We could do it as 3 times 14. We could do 4 is not going to work because when we pulled out 2, it wasn't even. 5 is not going to work. We could do 6 times 7, and then because those are right next to each other, we know we got them all. So then the divisors of 42 would be 1, 42, 2, 21, 3, 14, 6, and 7. I always write them as pairs. You can write them in order if you want. That's what your book will do. But then when we look at 17, the only way to write 17 would be 1 times 17 because everything else fails. So then the only divisors of 17 would be 1 and 17, which means that this is called prime because the only divisors are 1 and itself. Okay, so prime numbers are numbers that only have divisors of 1 and itself. Alright, we're still in lesson 6.5. So now what we're going to do is we're going to define what a composite number is. So prime numbers are numbers that only have divisors of 1 in itself. So that's only a select group of numbers. And then the composite numbers have divisors more than just 1 in itself. So divisors more than 1 and itself. So they have other divisors. So for example, now we're going to determine which of these are composite numbers. So we have 41, 51, and 119 as our numbers. So the first one we are going to look at is 41. So when we think about 41, we go, okay, well we can do 1 times 41. It's not even, so anything even is out. Okay. When we try to do anything else, it doesn't break up, so that means this one is prime. We'll talk about how to test all the factors and do all the divisibility rules here in a minute. Okay. 51, we know we can write as 1 times 51, so we know it's at least one of them. And then we try to pull a 2. That doesn't work, but we try to pull a 3. If we do 51 divided by 3, you should get 17. Okay, 51 divided by 3 is indeed 17. Okay, so that means that this one would be composite, because that's all we're determining here. We only need one other set, or one other number that's a factor for it to work. Okay, so then 119 is a little bigger. We know we have 1 times 119. 2 won't work. When we try to do 119 divided by 3, we get 36, remainder 2, so that's out. 4 won't work because it's not even. 5 won't work. Okay, 6 won't work. Maybe 7. Let's try 7. Okay, so when we divided 119 by 7, we got 17, and that tells us it's composite. So now the next thing we're going to look at here is divisibility tests. So I'm going to pause it here, so give you a little bit of a break, and then we'll do a new video with divisibility tests.